Hi, in this video, we will see how we can handle time series data that has regular gaps. Regular gaps are pretty common. A typical and well-known example is stock market. Stock market typically operates during the daytime and is closed during the evening and night time and also on the weekends. So what you will see is basically the data is generated during the daytime and the remaining time the data is not present, right? And similarly, there are a lot of industries that do not work on shift basis or do not work on weekend. Maybe they work only during the normal daytime and the remaining time there is no data generated. So data with regular gaps is pretty common. And in this video, we'll see how we can handle such scenarios. So let me get started. I'm going to use Facebook Prophet in this video to model data with regular gaps, but it can be done in any model. It can be done typically with your regular Harima model or any other model. I will talk about it as we come to that scenario. But in this video, I'm going to use Facebook Prophet to model it. So I'm just importing the typical packages Matplotlib and Plotly Express to visualize the data. I'm just using NumPy to kind of play around and process the data, and Pandas to load the data and view the data. So this is the typical package I'm importing. I am going to use a data set that is available in my GitHub repo. So this is the location of the data set. It is a energy usage data set, and you can just follow the same URL and then you can download the data set and you can as well use it. And in this there is a date column called a date, and what I am telling past dates, and I am asking to infer the date time format. So if I don't give this, the data will get still loaded, but only thing is the date field will come as object rather than date time. And then you have to handle it outside of the pandas data frame, so that you can do some analysis on the data which requires date as x value or date dimension to it, right? So here I'm setting it at the pandas data frame itself, so when the data is loaded it will be in a date time format. So if now once I fill the info, if you see basically over here, the data set is loaded and the date column is coming as date time. If I don't give those two parameters, it will come as object, similar to what it is for day, right? So this is the information about the data frame. Let's quickly visualize the data. Let's quickly print the data frame. So this is how the data looks like. Basically, you have the date column, you have the energy column, you have the temperature, humidity, and what day it is. Basically, day is just like based on the date, the day is extracted. The data is between Monday to Friday, and Saturday, Sunday also has values, but it has zero in this data frame, which I will show you once we visualize the data. So this is how the data frame looks like. Let me quickly print the top 15 records. Now, if you see this particular data frame, you can see basically on the data starts from 5 o'clock in the evening on 11 January 2016, and it's still 6 o'clock. And after that, the next day data starts from 9 o'clock to say like 6 o'clock, and then again the next day starts from 9 o'clock to 6 o'clock. So in this in this particular data set, the data is available only during the daytime from morning 9 to evening 6 p.m., and after that the data is not there. So basically these are regular gaps. Maybe the particular industry where this energy data is extracted, it operates only during the daytime and not during other time. So that's why you are seeing this data, and there are regular gaps in the data, right? Let me quickly visualize the data. To visualize, I'm using Plotly Express. I'm giving my x-axis as date, my y-axis as energy usage, and then when I click on the particular line in the data, I'm just hovering based on the day, whether it's a Monday, Tuesday, Wednesday, Thursday, and the temperature what it exists that time, right? So this Plotly Express, and one good advantage of Plotly Express is what I can give is I can give an more kind of an slider functionality. So here I'm giving range slider. What I'm telling is, if when I click on the top, I will show you in the graph. When I click on the top, I can set 1 day, 14 day, 1 month, and 3 month based on the range I have defined over here. And that's what I'm doing. I'm basically creating a slider object. I'm creating a range selector, and I'm giving multiple ranges. So let me run this and I will tell you how it looks like. If you're seen stock market data in Yahoo Finance or Google Finance, it will look similar to that. If you see, this is the slider. So I can select 1 day data, 14 day data, 1 month data, 3 month data, or I can say all, right? So this gives me to a better way of analyzing the data. And apart from that, I also have a slider in the below where I can just move the slider and move to a particular data point. I can do that as well, right? So let me first check 1 day data. So if you see this 1 day data, typically most of the time the data is flat, but that 9 o'clock, what I see is 9, 10 o'clock, I see the data is increasing, and then it's going up till 6 o'clock, right? Let me go for 14 days data so that we get a better understanding of data. So now if you say 14-day data, you can see like most of the time on Saturday, if you see over here, the energy usage is completely zero. Saturday and Sunday. So Saturday and Sunday, the maybe this particular company is shut and there is no data generated, right? And during the remaining time also, it's high. Only at around 9 o'clock, the data goes above zero level and it kind of increases and then comes down again at 6 o'clock. And similarly, the pattern is that Saturday and Sunday again it is zero. The next Saturday and Sunday. So basically, the data is, as we saw, the data is available only from 9 o'clock to 6 p.m. And then on Saturday, Sunday, the data is completely zero. And you can see some peaks over here, like there's a peak at 5 o'clock, and there's a peak again at 5 o'clock, there's a peak again at 5 o'clock. So basically, within a daily value, there is also some kind of peaks during the day, maybe some daily seasonality that's between 5 o'clock or 5 o'clock here. You can basically over around and see there's a 4 o'clock peak. So looks like there is some peak around during the evening time between 4 to 6 o'clock. That's what we are seeing over here, right? So this is how our data looks like. The data is available only from 9 a.m. to 6 p.m. and Saturday and Sunday there is no data. So let me quickly visualize all the columns that we have. We have temperature column and everything. So for that, what I'm doing is I'm setting the date column as index. The reason I need to have a date time as date, because I can just set it as an index and I can do analysis at the date dimension, and that's the reason. Otherwise an object will also do, right? So I'm setting the date as index and I'm creating subplots over here. And if you see the subplots, these are the three values that we have. We have energy, we have temperature and humidity. I also have weekday. Weekday is a categorical column, so it will not come in the plot. So only the numeric column will come. So if you see basically over here, I have some peaks, and then there are some like kind of zero value, that is weekend. I have multiple peaks, and when the temperature is kind of lower, looks like the energy usage is higher, and as we approach summer, right, maybe the energy usage is relatively lower. That what the plot looks like over here, right? And humidity does not seem to have any effect on temperature, effect on energy, but let's see like let's see if we can use that and make our model better, right? I'm also going to show you, along with the univariate, can we also use multivariate and see how the outcome is better. So let's see, let's, as we go in, we'll go to the details of it. So that's my data frame. If I look at the data frame, this is how it looks like. Again, the same thing that we saw, only thing is date is set as index in this. But let me go to the original data frame now, right? So now what I'm going to do is, first I'm going to create some additional features. If you see, we have the day column, right? The day column, if it's Saturday and Sunday, I'm going to create like an more kind of a numerical encoding. For other days, I'm going to set it as 1, and for Saturday and Sunday, I'm going to set it as 0. For that, what I'm doing is I am creating two filter objects. One is if the day equal to Saturday, and second is if the day equal to Sunday. And then I'm creating a numpy.where condition. I am asking if the day filter 1 or filter 2, then set as 0. I'm creating a new column in the data frame called weekday, and then I'm setting it as 0 if it's Saturday or Sunday. Otherwise, I'm setting it as 1. Suppose this, you can see basically there will be a new column added to a data frame, and you can see basically whenever there's a Monday weekday, I'm setting it as 1. And let's see like how it looks like on a Saturday or Sunday. So in a Saturday or on Sunday, the value is set as 0, and you can see the energy usage is also set as 0, right? But temperature is as value, because temperature is captured by an external element, and the temperature capture will always be there, right? But the energy usage is almost 0, right? So the one variable I have created. The second variable, what we saw in the graph when we were going to the graph, is during the evening time, typically the energy usage is higher. That's what we saw. So to accommodate that, I'm going to create one more variable. I'm going to basically take the date column, and I'm going to take the hour column from the date, and then I'm going to create 3 bins. we have data from 9 a.m. to 6 p.m. So basically, if when I create three bins, there will be 3 hour window for each of the bin. So 9 to 12 will be one bin, 12 to 3 will be one bin, and 3 to 6 will be the third bin. Right. So that's what I'm doing here. I'm taking the data. I am calling the pandas.cut method. I'm calling the hour and asking it to create three bins over here. And I'm assigning it to the time bin variable. That is the first thing. Now, what I will have is I will have 0, 1, 2 as bin. Basically, it does a numerical encoding. But if I just pass that to my data frame, I can still do that because we know like 4 to 6 has higher precedence than the remaining time. But maybe that's not the right approach, right? It's better to one not encode it because the 9 to 12 and 12 to 3 might not have higher precedence, might have equal precedence. So that's why what I'm doing is I'm taking this value, I'm creating dummies. So when I create dummies, it will take this time bin column and create three different columns over here. And then I'm assigning it to a variable, and then I'm joining that particular time underscore OH to the original data frame. So once I do that, you can see basically I will have three additional columns in the data frame as here. Right, so basically the time bin is 201, but I am doing a one not encoding, telling which bin it falls into. So this is how my data frame looks like now. Right, and finally what I'm going to do is I'm going to create a final data frame, but I'm going to leave the intermediate column and select only the required columns. I am also going to rename my date column as DS and the target column energy as Y. The reason is Facebook Prophet requires your data column, date column to be DS and the target column to be Y. Right, so that's the reason I'm renaming these two columns over here. So once I do that and run it, I have my final data frame, and the final data frame looks like this. The date column is DS, the target column is Y. These are all something like additional regresses we are going to add to our Prophet model. Right now, I'm going to split the data frame into my train and test. So basically, for the train, I'm taking data from January to May, so some date, and then greater than the May date, I am just taking it as test data frame. So let me run this, and once we see the shape of train and test, you can see my train has 12,042 records and test has only 130 records, right? And then I'm going to print the test value. Now let's see like how to handle when we create a future data frame. But when we deal with like the multiple ways of handling the weekend value, right? The weekend value is zero. If you take a typical stock market scenario, it's okay to take Friday data and propagate into Saturday and Sunday. The reason is basically we are just using the previous value to predict the next day's stock price. But if you take in the energy usage in this case, you don't want to propagate your previous day data on Saturday and Sunday because it looks like you're actually using energy on Saturday and Sunday. So you typically want to keep that value as zero only. So you can either do that or you can add like additional holiday calendar in Facebook Profit or special event calendar telling okay these days are off, but there'll be too many weekends and you don't want to add that. That's the reason I created this particular variable to tell it's a weekday or not. You can also delete it from your future data frame, which I will show you how you can do that. Right, so I am importing from the Profit library and I am creating a model object from the Profit library, and then I'm going to fit the train data in this. So the train data frame which I have created, I'm going to fit in that. Now what I'm doing is, if you see on the top, I am telling my test data is 130, right? And the last day my test data, the total data that I have is till 27th May 2016. All right. Now, when I make my future data frame, because I have test data as 130, I want to predict it for 130 periods. So, but when I do this 130 period prediction over here, and then what I'm telling is I'm telling the Profit model dot make future data frame. So it will take the last value based on the train data fitted, and it will create 130 new dates at a frequency hour because our data is hourly frequency. If you see on the top, we have data in the hourly frequency over here, right? And we have data from 9 a.m. to 6 p.m. So what it is going to do is it's going to create 130 future periods. But when I run this over here, If you see over here, it's creating data for morning 12 o'clock, 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, and for 19, 20, 21, 22. It's creating data for the entire 24 hours period. But I have data only for say like 9 hours period from 9 o'clock to 6 o'clock, right? So my future data frame has a lot of value, and if I just use this future data frame, right, and then start predicting it. So one thing is the data is only till 20 May, but if you see my actual data frame, the data is till 27th May. So in order to accommodate that till 27th May, the first thing I need to do is I need to increase my periods. I cannot have 130 period as I will regularly have based on my test data frame, right? I need to increase my period. So what I'm doing is on a rough approximate, right? I have 9 hours data, and typically this is generating for 24 hours data. So I just need to increase the data from 2.5 times based on that, right? So I'm just making the period as 312, frequency as hour, and then I am printing the output. The first thing that I'm doing is that one. Now I have data till 27th May. My problem of the time is not solved. I still have data for 5 o'clock, 6 o'clock, 7 o'clock, 8 o'clock, where in the original data frame now I don't have. So if I start predicting based on only this data frame, not accounting for the gap, right? So what I'm doing is I'm taking the future data frame that I created, I'm calling model.predict, and I'm generating the forecast. And then in the next one, I'm plotting the forecast. So in this case, I have not handled my regular gap set, right? I'm just going to forecast as it is. Now, if you see this forecast, this is how the forecast looks like. The first thing is the data seems to be cut off till 300. It's not able to find any peaks in the data, right? I'm using a univariate now. I'm taking only the target variable and trying to predict. So the output forecast, basically this is the 95 or 80% confidence interval. By default, Facebook profit creates 80% confidence interval. This is the actual prediction. This is the 80% upper and 80% lower limit confidence interval. And if you see over here, typically on the remaining day, on weekends and other places, it seems to be touching zero. But on these two forecasted days, it's going way below, right? Now we are not handled anything with the regular gaps. One is the prediction is not great. It has not been able to predict the peaks. Second is it is also doing some prediction for the remaining hours. So let's go and check it out how it looks like so that we get an idea what is it forecasting. So from the forecast data frame that I generated on the top, I am printing the y-hat, which is the predicted value, y-hat lower and y-hat upper. And if you see this y-hat lower and y-hat upper, you can see basically 0, 0, 0, 1, 0, 2, 0, 3. It should ideally be 0 because there's no energy usage. But it has started predicting 84s, 117, 141, 130, which is absolutely wrong, right? So in order to handle this, what you do is you create a future data frame only for the values you have data. And what in this case, what I'm doing is I'm just creating a copy of my future data frame. I'm creating like future underscore final. And then I am selecting from the data frame only where the hour is greater than 8, that is 9 o'clock, and the hour is less than 19, right? Now, Facebook Prophet by default will handle this gap. Now, what I am handling only here is only the weekday regular gaps, right? I'm not touching the weekend at all, right? Weekend I will come to that later. So on any day, I'm just taking data only between 9 o'clock greater than 8 and less than 19, that is 18 hours, 6 o'clock, and I'm creating my future data frame. In this case, I am going to tail my last 50 records, and you can see basically I don't have any data apart from what my trained model had. It had data from over here like 9 o'clock to whatever date. Again, 18 hours as a cutoff and everything. I don't have that 0, 0, 0, 1, 0, 2, 0, 3 hours. Now let me make a forecast based on the future data frame final that I created, and let's see how it looks like. Now, one thing is you can see the peak over here has substantially reduced, not to a great extent, but decent. If you see on the top, basically the bottom peak was pretty high. It was almost touching minus 100 over here, and the 80% confidence interval was minus 200. But if you see over here, it is around minus 100 is the confidence interval, and this is almost like close to zero, right? That is one part. But my forecast has still not improved because I'm just using energy to predict the future, right? Now maybe the energy is not able to capture the previous value of energy, the t minus 1, t minus 2, or whatever value that we have. Maybe it's not able to capture the future value property, the future variance properly. So that's where maybe I need to go for multivariate analysis, right? Maybe I need to add additional features that can better capture this model. So before going there, let me print the components of the model. So the forecast that I generated, I can print the components. I can print the seasonality, trend, and other aspect of it. So this is how the component looks like. And if you see the component, looks like there is an upward trend and there's a lower trend. The trend is not constant. There is some trend in the data. The weekly seasonalities, this seems to be not much. You can see on Saturday and Sunday it touches zero, but on other days it's almost like closer, even though like 0 and 50 are higher, but still weekly seasonality is not there. But in the daily seasonality, maybe you can see like towards the evening time, 5 o'clock or 6 o'clock, maybe it increases, right? There is some kind of daily seasonality, right? So now what we can do is we can also like print the forecast over here. And the forecast, if you see, it will be only for the duration that our train data frame is there. So we are not predicting for anything above 6 o'clock or below 9 o'clock on a daily basis, right? So that this way our daily regular breaks are handled, but still we have one work to do: the weekends, right? So in this case, if I go back and say like for print for the weekend, right, I'm just adding a new variable called day name based on the date. So whether it's a Saturday and Sunday, and then I'm querying for Saturday. Now if you see on Saturday, it has still done prediction because we are not handled Saturday yet. The y at value is still there, right? Now either we can just predict as it is and then ignore the Saturday value because that's going to be there, or we can go back to our future data, the data frame that we created, and then we can remove the Saturday and Sunday data completely and predict it. That is like one way of doing it. But still we have a problem. The variance is not completely captured over here. So how can I make that variance capture? And that's where we are going to enter now, more like a multivariate, or we are going to add additional regresses to our model. That's what we are going to do. And for that, what I'm doing is I am creating again a profit object. I am telling my seasonality mode is multiplicative. The reason is there's some amount of trend in our data, right? I want to capture the trend. I can give the default to an additive, but I want to try with multiplicative over here because there's some trend in data. And then I'm telling daily seasonality equal to true because we are seeing some kind of daily seasonality, and I am just giving a confidence interval of 95%. And I am adding additional regresses, whatever we created. I am adding weekday as additional regresses where we created a 0 for weekend and others day 1. Temperature I am adding as additional regressor, and the time bin that I have created 3 bins. I am adding one not encoded value. I am adding that as additional regresses. Now remember, like when you are adding additional regresses, when you are predicting a future value, this additional regressor value must be known at that time. Now in the case of time bin, it's easy because tomorrow or day after tomorrow, I'm just binning the 9 to 6 o'clock by 3 bins. I can just add the bin directly. The weekday is also easy because I know like in future what date will fall on Sunday or Saturday. I can just get it from the calendar object. But the temperature, I need to know the future value. And maybe I go to external sources and take, okay, what will be tomorrow's temperature, day after temperature. That is also quite possible. Now temperature forecast may not be accurate, and that's where you need to leave some kind of uh, some kind of uh, some kind of like buffer telling, okay, what is the confidence you have in the temperature prediction, and maybe you want to run some simulations over there. But that is something like we will talk in a future video, right? So these are the values I am adding now, and let me run this. Let me start training it, right? So I am training the model, and now what I'm going to do is I have to go back and add this particular all this variable to my future data frame also, right? These are all in the training data frame, but to predict the future I need to know this value so that I can predict my target energy use, right? So what I'm doing is I'm taking the future my future data frame, and then I'm just removing the index out of it, and then I am adding all of this value, the final values, to my future final data frame as well, right? So basically when I create a future data frame, it will just give me the future dates. If along with the future dates I am adding weekday, temperature, the bin of the all the columns, So once I add this, let's print the future data frame. So in the future data frame, you will see all of these values are present now, right? The temperature bin 0, 1, 2, 3. Now I can use this value to predict the future value of energy. So let's see how the forecast looks like now. We were seeing the earlier forecast were cut off to 300 level, right? That's what we saw. Let's see if it is able to capture the variance. Now, if you see over here, almost the Saturday and Sunday is far better. All the other days is far better. It's close to zero, similar to other, right? That is one part of it. Now, earlier it was cut off, the Y value was cut off till 300. Now, what we are seeing is it able to capture some of the fix, but still not perfectly done, right? Because energy usage can be sporadic based on demand of other machinery usage and everything, based on product demand as well and everything, right? So maybe the data that we have is not able to capture completely, but it is still far better than the univariate analysis that we did. By adding this additional value, we are able to explain some of the variance better, but still not perfectly, right? So that's why, and that is also coming at the higher confidence interval. So maybe we need to add additional variables which we don't have. We need to go and collect data. There are multiple other aspects of it, right? But now we added an additional column to define Sunday or Saturday, right? But let's see whether that was handled. Now, even if you run this, the Saturday and Sunday in this case will not be handled completely. You will still have some low value of Saturday and Sunday, because the regresses that we are adding, it creates more kind of a linear equation. Even though we are telling, okay, the weekend is zero, maybe the coefficients for that will be nullified, but there are other coefficients which will be still used to predict Saturday and Sunday. And this is the reason I was telling, maybe you need to go back to the future data frame and do the same handling that you did to your weekday, so evening 6 o'clock to morning 8 o'clock values, right? Maybe you want to remove it from the data frame, or just in the prediction, just ignore this. Don't consider any value for Saturday and Sunday, right? So in what I was what the purpose of this video was to tell, basically the regular data gaps is pretty common. How to handle this data with regular data gaps using Facebook Prophet? You make sure your future data frame is created that is mimicking to your training data frame or real world instances. And there are maybe some cases where you can propagate your last working day value to Saturday and Sunday, typically in the stock market, because the closing price on Saturday and Sunday will still be the same, but not on other days. So just want to show a quick example. You can do the same thing with Arima also. You can add additional regressors to tell, okay, these points are not significant or something like that. But Facebook Prophet provides you a easy mechanism to handle such scenarios. Thank you very much.